Hey guys, and welcome back. My name is Miss Danielson, and today we're looking at solving word problems by setting up and solving algebraic equations. So I hope you joined us for our previous lesson on solving linear equations. If not, I'm linking that down in the description box below, so you can check that out before we get started with a couple of examples. We're starting off with a really simple example where they tell us that we have some unknown number which we'll add 7 to, then divide that answer by 4, and the result is 3. Let's write this as an equation. In order to write an algebraic equation, we need to first start by identifying some variable, that is some letter, that we're going to use to represent some unknown number. In this question, there's a number that I started by thinking about, but I don't know what that number was. In algebra, we very often use the letter x to represent some unknown number. So here I'm making a let statement to make it clear x is the number that I first thought of. Then as it says in the question, I added 7 to the x, then divided that answer by 4, and the result was 3. So as you can see, this is a fairly straightforward question where we're just naming a variable and performing the operations in the order given in the question. Now, if we want to solve this equation to figure out what number we were thinking of, remember x is the variable that represents the number we were thinking of. We want to rearrange this equation so that x is by itself, and we can see what x is equal to. So to undo this equation, following the reverse order of operations, as we can see in the question, the first thing we did was add 7, then we divided by 4, and then our answer was 3. So going backwards through this, getting rid of that 4, the opposite of divide is multiply. Then to get rid of the 7, the opposite of add is subtract. So x is 12 minus 7. So the number that I first thought of must have been 5. Let's try another example, and be careful because it looks very similar, but it is different. This time I think of a number, I divide it by 4, and then I add 7, and the result is 3. Sounds very similar, doesn't it? Well, let's go through our steps then. Let's first start by identifying the variable that we're going to use to represent the unknown number. Again, I'm just going to use the letter x, but making it clear that I'm letting x represent the number that I first thought of. So I started with x, and in this question, I divided x by 4, and then I added the 7, and the result was 3. I hope you noticed that the order of operations was different here. In this case, I first divided by the 4, and then I added the 7. So when I work backwards to solve this equation, first I'll get rid of the 7, and the opposite of adding 7 is subtracting 7. So that's x over 4 equals negative 4. Then I'll get rid of the 4, and the opposite of divide is multiply. So I have x equals negative 4 multiplied by 4, and negative multiplied by a positive will be a negative answer. So the number I first thought of was negative 16. Here's a slightly more challenging example because we're putting these questions into context. My aunt is 9 years younger than my mother, and their combined age is 103. Work out each of their ages. So in this question, they didn't specifically tell us that we needed to write an equation, nor did they very clearly tell us what that equation would be, but that's how we're going to need to start. So what information was given? Clearly, we're told that my aunt is 9 years younger than my mother, and we're told that their combined age is 103. What does the information equal to? Well, we know that the combined age is 103, so we should be able to write some kind of equation of adding their ages together to make an answer of 103. So let's start by writing let statements to identify the variables that we're going to use to represent the unknown numbers. In this case, I don't know what my aunt's age is, so I'll say let A equal my aunt's age. Nor do I know my mother's age, so I'll let M equal my mother's age. When choosing a variable, it's always a good idea to choose a letter that's going to remind you of what it represents. So A for aunts and M for mother. My aunt's age plus my mother's age must add to make 103. That's a nice simple equation. However, we can't possibly solve this equation because there are two values that we don't know. We don't know my aunt's age and we don't know my mother's age. It's generally best, whenever possible, to write an equation with as few unknown variables as possible. If there's only one unknown variable in an equation, we should be able to rearrange and solve it. But if we have two unknown variables, you'll need two equations. That's two good hints at what those values could be. I do, however, have another hint. Remember in my question, we're told that my aunt's age is 9 years younger than my mother's age. So we could say that A is equal to M minus 9. My aunt's age is my mother's age minus 9. And I can replace A in this equation with the expression M minus 9. That way, I've got an equation which may look a bit more complicated, but it only has one unknown value in it. So we can simplify this equation and work it through to find the value of M. So simplifying this, I don't really need these brackets here because there's nothing multiplying by these brackets. There's no minus sign in front of these brackets. I've just put those brackets there to show that instead of the A, I've replaced it with this expression. So I can go ahead and simplify this by grouping like terms. M plus M is 2M. So 2M minus 9 is 103. Let's now try to get the M on its own. Remember, M is my mother's age. So if we get M on its own, we'll know how old my mother is. So first, M is being multiplied by 2, and then the 9 is subtracted off. Let's work backwards and undo those operations. The opposite of subtracting 9 is adding 9. So 2M is equal to 112. To get the M on its own, that 2 in front of a letter is multiplying, so the opposite of multiply is divide. M is equal to 112 divided by 2, so my mother, M, must be equal to 56. My mother's 56 years old. Now be careful with questions like these. We were asked to work out each of their ages, so we also need to work out my aunt's age. So if M is equal to 56, remember that my aunt, A, is equal to M minus 9. So A must be equal to 56 minus 9. That's 47. So I know my mother's age, she must be 56. I know my aunt's age, she must be 47. And I could check my answers as well by substituting these values into the original equation. 47 plus 56, does that give 103? Yes, it does. Perfect. Let's try another challenging question now. A family of 2 adults and 3 children buy tickets for the cinema, and it cost a total of 56 euros. Write an equation for the total cost of their tickets. Okay, before we get started, what information was given? Well, we know how many people are going to the cinema. There are 2 adults and 3 children. We also know what this information is equal to. The 56 euros represents the total cost of the 2 adults and 3 children's cinema tickets. So we can write an equation based on the information given, but first let's start by writing a let statement to identify the variables that we're using and what they represent. So let's let A equal the cost of a single adult's ticket, and let C equal the cost of a single child's ticket. Note that I didn't just write A equals adult and C equals child, because that could get confused in thinking that A is the number of adults and C is the number of children. So always write a let statement to make that very clear. Now let's write our equation. There are 2 adults and 3 children, and altogether the cost of the tickets adds up to 56. So 2a plus 3c equals 56. And that seems to be a nice, clear equation for us. We even use letters that make sense to us so we can clearly see that this is 2 times the cost of an adult ticket plus 3 times the cost of a child's ticket. However, we can't solve this equation unless we've got one single variable. So maybe we need some more information here. Given that the cost of an adult's ticket is twice that of a child, write a simplified equation and solve it to find the cost of the child's ticket. Now we needed that added given information to be able to solve this equation. So now with that added information, let's try to write an equation that's only got one variable. That is, it's only got one unknown value. How has that information helped? We were given the information that an adult's ticket is equal to 2 times a child's ticket. So A is equal to 2C. That means we can replace the A in our equation with 2C, and then we'll just have an equation with one variable. Now we've got an equation that's only got C as a variable. I use brackets when I replace the A with 2C here, and notice that there's a 2 in front of this bracket. 2 in front of a letter means 2 times that letter. 2 in front of a bracket means 2 times what's inside that bracket. So 2 times 2C is 4C. So 4C plus 3C, we can group those like terms together. 4 plus 3 is 7, so 4C plus 3C is 7C. 7C equals 56, so to get the C on its own, the 7 is multiplying, the opposite of multiply is divide. So C must be equal to 8. Remember, C represents the cost of a child's ticket. Always finish by rereading the question to make sure that you've answered it correctly and completely. In the question, we were asked to solve to find the cost of a child's ticket, and we've done that. If they had asked us to find the cost of an adult's ticket, we would have another step to go. An adult's ticket is twice a child's ticket. 2 times 8, 16. But as we're just looking for the child's ticket, let's not confuse our answer. The child's ticket costs €8. Let's get on to some practice now. Let's first read through the questions together. So for question 1, think of a number, double it, then subtract 8. What was the number I was thinking of? If my answer is 6. Question 2 looks very similar to that, but be careful with your order of operations. This time I think of a number, I subtract 8, then I double the result. What number was I thinking of if my answer is 6? Does the order of operation affect your answer? Question 3. I think of a number, half it, then add 7. What number was I thinking of if my answer is now 10? Question 4. I think of a number, add 7, and then half the result. Again, the order of operation is different here from question 3. Still, what was the number I was thinking of if the answer is 10? Question 5 is an applied question. 3 pizzas and 4 drinks cost €29 altogether. Find the cost of each pizza if each drink costs €2. So take care setting up your equation for that one, starting with your let statements to tell me what letters you're using and what they represent. Reread the question once you've finished answering it to make sure that your answer is complete and appropriate. Question 6, again another challenging applied question here. A group of 3 girls have a mean age of 7 years old. What will the new mean age be if a 3-year-old girl joins the group? If you need a reminder about this, remember that the mean age is the average where we add all of the values together and divide that by the number of values. Go ahead and hit pause. You must copy the questions. The wording is important because if you set your equation up wrong, we'll want to see where did you go wrong from the question. So copy the questions, write your let statements to identify the variables that you'll be using, set up your equations, and then see which operations are being performed on your variables and work backwards to undo those operations to get that variable on its own. Remember to reread your question once you've finished to make sure that you've answered it completely. Okay, so go ahead and hit pause now, work that through, and hit play when you're ready to take it up. I hope you had a chance to hit pause, because here come your answers. For question 1, I'm going to use the letter X to represent the number I thought of. So I doubled the value, then subtracted 8, and my answer was 6. To get X on its own, first I'll add the 8, then I'll divide by the 2, and the number I started with must have been 7. For question 2, again, I use the letter X to represent the number I thought of, and I subtract 8 from that value, and then I double the answer, so I hope you remember to use brackets. If you forgot about the brackets and you want to hit pause to make any corrections now, please do. Now working this through to find the value of X, first I'll simplify this equation by expanding those brackets out, so 2 times X and 2 times minus 8. Then I'll get X on its own by first adding the 16 across, then dividing by the 2. Now there is an alternate method for this. So if you haven't done the working this way, maybe you started by moving the 2, thinking that X has 8 subtracted from it and then it's multiplied by 2. You might want to undo the multiplication of 2 by dividing by 2. Then get rid of the 8, which is subtracting, opposite of subtract, add, and your answer in either case will be 11. So it doesn't matter if you first expanded out your bracket or you first moved the 2 across, and I would only really recommend this if you can actually divide this value by 2. In this case we can, and it seems like it's actually even shorter to do it this way. So keep that in mind, there is more than one method to the right answer. However, we did not affect the order of operation. Notice that the question above was very similar, but the order of operations was different, and our answers are different. For question 3, again, the number I think of, I'm going to use the letter X, half it, and add 7. And my answer is 10. To get X on its own, first I'll subtract the 7, then I'll multiply by the 2, and the number I started with must have been 6. For question 4, again, I'll start with the letter X, and I'll add 7, and then half the result. So first I added the 7, then I divide that answer by 2. To get the X on its own, first I'll undo the division, so multiply by 2. Then I'll get rid of the 7, opposite of add, subtract. And the number I started with must have been 13. Once again, you can see that changing the order of the operations does affect our answer. Question 5 now. I've chosen to use the letters P for the cost of a pizza and D for the cost of a drink, just to set up an initial equation that's fairly easy and straightforward. 3 pizzas plus 4 drinks cost 29 euros altogether. Now, obviously, I can't solve this equation because there's more than one unknown variable. So I need to find a way to write an equation that has only one unknown variable in it. We're given another hint here. We're told in the question that the cost of each drink is 2 euros. So let's replace the D's with 2. Now remember, 4 in front of the letter D means 4 times D. So 4 in front of the 2 in brackets means 4 times 2. 4 times 2 is 8. So 3p plus 8 is 29. To get the p on its own, first we'll move the 8, we'll minus it. Then we'll move the 3 and divide. So p must be 7. Each pizza must have cost 7 euros each. Now question 6 was a really challenging one, so I hope you at least gave it a go. I'm going to start by setting up my variables. We're talking about a group of 3 girls with a mean age of 7 years old. So I let A represent the total age of the first 3 girls. Now the reason I did this is because I know that the mean is equal to the total divided by the number of values that we've added together. So if the mean of the first 3 girls' ages is 7, I could write an equation that shows that the total of the first 3 girls' ages divided by 3 must be equal to 7. Now the reason I did that is to help me find out what the total of the first 3 girls' ages. So rearranging this equation, A is being divided by 3. The opposite of divide is multiply. So A is equal to 21. The first 3 girls have a total age of 21. Now, how does that help me? It might help to reread the question. What will the new mean age be if a 3-year-old girl joins the group? So I know I already have a group of 3 girls where their total age is 21. If I add a 4th girl to the group, what will their total age be? And what will the new mean be? Well, the new mean of the 4 girls would be the total of their 4 ages, so 21 plus the 3, divided by 4 because they're 4 girls. So that's 24 divided by 4, which is 6. The mean age of the 4 girls now is 6 years old. That should seem reasonable because if the previous mean was 7 and we added a new girl who was much younger than 7 years old, you would expect the mean average age to go down. How did you do with that? Please let me know down in the comment section if there's anything that's a little bit unclear for you. Otherwise, well done, keep practicing, and I'll see you soon.